Hey everyone, Angie here to give you an introduction to push buttons. In fact, we're going to add a push button to the circuit that you built in the previous video. We'll also talk about the concept of open versus closed circuits and why circuits need to be closed in order to work. Let's get started. Let's take a look at the circuit you just built. It has an LED and a resistor, and the LED turns on and stays on when I turn on the power on the NLAB. But let's say I'm an engineer designing a product, and this is not the exact final result that I'm looking for. Let's say I'm designing a device where the light only turns on when I'm pressing a button. Kind of like this remote control. You can see that this little light here only turns on when I'm pressing a button. What I'm trying to do from a design perspective is give the user an indication that them pressing the button is actually doing something. That's what the light here is doing. So as a design engineer, I get this idea and I know that I have to somehow add a button to my circuit. How do I do that? It's actually pretty simple. We don't actually have to change very much about our circuit. The first thing I'm going to do is remove the resistor and the black wire and set them aside for now. Now go into your kit and find your push button. They look like this. They might come taped to a piece of cardboard. You might notice if we zoom in here that these push buttons have funny, zigzaggy looking feet. These funny feet won't fit in our breadboard, but if we cut off those feet, these legs will fit in perfectly with our breadboard. So now we find our wire cutters in the kit, and we use this portion of the wire cutters to cut the push button off the tape and remove those squiggly feet. And there you have it. So now we're going to put this guy and have one leg share a row with the LED. It doesn't matter which leg. You can put push buttons in any way. And you put the other leg in any row that hasn't been used yet. The rest of the circuit is built the exact way it was before. We have the resistor share a leg with the previous component, the push button. We start a new row, and then we have a black wire going from there to ground. Okay, now let's turn it on. Oh, the LED isn't turning on. Why is that? Well, you probably already know the answer to this question. Your boundless curiosity probably led you to push the button already, and you'll see that the LED only turns on when you press the button. You'll see that the circuit only works while the button is pressed. This is because a circuit needs to be closed, not open, in order to work. I'll show you what I mean in the Lightboard Studio. This is what a push button looks like on the inside. It consists of 3 pieces of wire, one here that's actually attached to the button that you press, and then another wire here. Now let's draw the circuit. We know that we started at 5 volts, and then we moved on to our light, which I'll represent with a light bulb. And then we went to our push button, and then from there to our resistor, and then to ground. When the button is not pressed, there's an awkward gap in the circuit here, kind of like a missing puzzle piece. If there's a gap anywhere in your circuit, this is what we call an open circuit, because there's a gap in it, which means current can't flow. But the moment you press this button, this awkward missing puzzle piece moves down to join these other 2 pieces of wire, and suddenly the circuit is complete. This is what we call a closed circuit. So current flows all the way through, and that enables the light to turn on. So pushing the button adds the missing puzzle piece and allows current to flow. I hope you enjoyed learning a bit more about push buttons and the rules of circuits. Until next time, I'm Angie. Thanks for watching.